Alright, welcome back to episode 35. So we just looked at currying in our last episode, and I want to say something, just a quick little video today about partial application, because you've probably heard the two terms, and if you're anything like me, when I heard the two terms, I did not realize what the difference was. I got them confused. I hear people often use these terms almost interchangeably. And so what I want to do is I want to just kind of give you some ways to think about what this partial application is. What is partial application? So if we have our curry function again from Ramda, and we have our same add function that we had in the last video, and we said that add now takes two arguments, and then we'll return the summation of them. And then if we curry that add function, then we say that the add function then takes an argument, it takes a number, and then returns a function that will accept the number and then return a number. And so currying is the act of breaking up functions like add, which takes two arguments, into it being a function that, given a number, will return a function that, given a number, will return a number. So currying is the act of doing that. Partial application is a term that people use to signify when you have given a function too few arguments, or so to speak, too few arguments. That would be in like an air quotes kind of thing. And we see that right here. So with our add2 function, we're calling curried and passing one argument. Curried, though, takes a number and then returns a function from a number to a number. So in a sense, what we did was we partially applied this to argument to our curried function, because what we returned back was not a value, was not a number, it was a function, not a number. And so when people say partial application, that's what they're talking about. Truthfully, I don't really like the term. I don't know that it's valuable, because it almost obfuscates what you're actually doing. It obfuscates the benefit of currying and the benefit of taking something from a domain and going to the codomain of your function. So in this case, if we look at curried, we call curried and we pass it a 2. That's a pure function, because every time we call curried and pass it one argument, let's say the 2, we're going to return the exact same function back. That's a pure function. It's deterministic and it's total. For every number that we pass it, it's going to return us a function that, given a number, will return a number. Now, does this still return a function? Absolutely. But in functional programming, a function is the way that we abstract things. So to define it as partial application, I think is missing part of the point, because there's a lot of benefit that can be had by returning a function. That is a way of, basically it's a factory pattern if you're coming from object-oriented programming. So you're providing it something concrete here, and it's returning you a function now based off of whatever this concrete value was. So then we could, finally, quote, fully apply to our add2 function. Now we could apply this 1 and get this 3, which is the final number here. But that's what partial application is. If you hear it, that's what people are talking about. Perhaps that makes sense to some people. It makes more sense. I think in the beginning that made sense to me, but as I've been doing more and more of it, I think it's a way to think about functions. It's a way to continue to think about functions as though they weren't curried, rather than it is a way to help you understand functional programming and get more into it. So anyway, that's episode 35. What is partial application? Let me know what you think. Does partial application make sense to you? Does it make more sense to you than the currying thing? Let me know. Basically, it's just talking about providing too few arguments to a curried function, so that the function is not fully applied. Anyway, thanks a lot, and hope to talk to you soon.